So we're going to review quiz 5. The first question is asking us to assume that we have f of x is a one-to-one function, and we're given if f of 6 equals 7, find f inverse of 7. Definition of inverse, your x and y values switch. So f inverse 7 gives you what? Exactly, good. Part B, we have if f inverse -4 gives you -8, then what is f of -8?
-4.
-4. Right. Easy, 4 points. Let's move on to question 2. We are given a linear function here, and we're asked to find the inverse. So first step, put it in terms of y and x. So we have y is equal to 8x plus 5. Second step, switch your x and y values. So now we have x is equal to 8y plus 5. Third step, we want to isolate our new y. Utilize some inverse operations, subtract 5 from both sides. So now we're looking at 8y is equal to x minus 5. And then let's go ahead and divide both sides by 8. So we have y is now fully isolated to be equal to x minus 5 all over 8. And then finally, we have our last step is put back into proper inverse function notation.
I have a question.
Yes.
You see in the solving process, if you because I just plugged it into.
Yeah, just give me 1 second. Guys, if you're gonna talk, just leave. Like, I really don't appreciate people talking over other students and talking over me. There's no point in coming to lecture. Yeah.
Once you find it, right? If the box, because it already has the F inverse like form in the answer key.
Yeah.
Really consider that and like the one that you have in your problem solving.
This one is going to be this y that you're putting back into your proper inverse function notation. Is that what you were asking, or?
Yeah, like
Yeah.
because since the answer box already has it.
Yeah, since the answer box already has it, you just have to write in x minus 5 over 8 and you're good. Yeah.
Would 5 minus x over 8 be acceptable if I carried over a different way? Because that's what I did.
5 minus x over negative
Yeah, negative.
8.
Yes.
Yeah, that should be correct. Yeah. Yeah, because if you factor out a negative from the numerator, then you have 5 minus x, and then if you had a negative in the denominator, a negative divided by negative cancels out. Yeah, same thing. Yeah.
So instead of x minus 5, I got x plus 5. How many points would that be on?
Not that many. Did you incorrectly do the inverse operation?
No, I just I did it quick.
And you wrote it.
Yeah, I just did
Okay.
x plus 5.
Yeah, that'll probably be at most 1 point. Yeah. Any other questions? Just if you made a similar mistake like that, our exam, when's our first exam? Thursday. So try to not make those mistakes on the exam because these quizzes, yeah, it's 15% of your grade. That's a big chunk, but the exams are worth way more. The exam should be about an hour long, but I'm going to double check with the math department today because we have an hour and 40-minute class and we also have to cover a whole lesson. So I'm curious if the exam is like an hour 15. We're only having 30 minutes to cover the lesson. Yeah, I don't know how that's going to work. So I'll double check and then I will let you guys know through an announcement. Yeah. memorize. Yeah, yep, that works as well. So this is the same as 1/8 x minus 5/8. All right. Any other questions? Yes.
X minus 5/3, like it's not together, but X minus 1.
X minus 5 is not together, you said?
Yeah, it's like X minus and
That is incorrect. Because you need to make sure you're dividing both of these terms by 8. X, X minus 5/8 is very different than, X/8 minus 5/8, which is the answer, X minus 5/8. Yeah. Really good questions, though. All right, let's move on to question 3, which is on the back page. We are once again asked to find the inverse, but now we're looking at a quotient function. So x plus 2 divided by x plus 6. Same procedure applies though. First step, put it in terms of y is equal to x plus 2 over x plus 6. Second step, switch your x and y values. Third step, we want to isolate our new y. So I'm going to go ahead and cross multiply. So we have x times y plus 6 equals y plus 2. Utilize some distributive property. Xy plus 6x equals y plus 2. Again, our objective is to get y all alone. So I'm going to subtract 6x from both sides and then also subtract y from both sides. So now we're looking at xy minus y is equal to 2 minus 6x. That left-hand side, we can factor out a y. And when we do, in parentheses, we're left with x minus 1. And then last but not least, we can divide both sides by x minus 1. And again, same as before, if you had some manipulation involving negatives, you would get full credit as well. So y is equal to 2 minus 6x over x minus 1, which is the same. If I factored out a negative, we're looking at 6x minus 2 all over, factor out a negative, 1 minus x. So 6x minus 2 over 1x. 1 minus x is also an adequate result. Okay. Last but not least, we want to put this in proper inverse function notation. So we get f inverse x is equal to, and I'll write both down, 2 minus 6x over x minus 1, or 6x minus 2 over 1 minus x. And then that's it. Any questions on this one? We haven't finished it up quite yet because we need to identify the domain. And finding the domain of any function, we have those two conditions. Denominator can't be equal to 0 and no negative number under even roots, which doesn't apply here because we have no radicals, but we do have a fraction. So we want to set 1 minus x to not be equal to 0, which tells us that x can't be equal to 1. This is our only restriction. So in interval notation, what does this look like? Negative infinity, comma, 1, soft or hard bracket. Soft. Union. Soft bracket 1, comma, positive infinity. And that's it. Yes.
I thought Inca was confused because I thought you had to take into consideration the x plus 6. You don't worry about the first one anymore because it's just asking about the inverse. Or-
Anytime you're looking, oh, you're talking about here? Yeah, when we're asked to find domain, you don't have to worry about the original function. If they asked you what is the range, then yeah, then you want to look at the original, because what's that famous sort of trick with finding domain and ranges of functions and their inverses?
The
Tristan.
X and Y values first, so the range would just be the X values.
Yeah, exactly. The range of the inverse is just the domain of the original. Yeah. Damaris and then Javier.
Number 2. My friend just like simplifies like the y plus 2 over the y plus 2. Like 1y, 1 over 2.
Also a really good question, because you can't break up that denominator. So y plus 2 over y plus 6 isn't simplified to 1 plus 1/3. If you wanted to break up the fraction, you can break it up into y over y plus 6 plus 2 over y plus 6. But you can't separate the denominator. You can only separate the numerators, but the denominator is, think about common denominators. They stay put. They're sort of like set in stone. Javier.
Since the question said it's still made and it didn't say like in interval notation, do you still get points off if you just put like can't equal to?
That's a really good question. Can you? Yeah, I'd give you full credit. Yeah. So I'm thinking like, would you get credit if you just put down the restriction? Yeah, I'll give it to you. I think that would suffice. Like,
Yeah, 'cause
if you put it in inequality form, definitely, but even within restriction, like I would give that to you too. Yeah. What?
It's a set notation.
Yeah, I'd give it to you too. Yeah. That builder notation. I don't see that often. I feel like students sort of stand clear of set builder notation. Any other questions? Yeah.
X minus 2 with the second part. Why did you put it on?
Why did I flip it around here? Right over here? That was just demonstrating that some students may have gotten their inverse to be 2 minus 6x over x minus 1, and then some may have gotten it to be 6x minus 2 over 1 minus x. These are both equivalent fractions. And so this middleman is me showing you guys how they're equivalent. What I did was I just factored out a negative from this numerator expression, and then I factored out a negative from this denominator expression. And what's a negative divided by a negative? Positive. So factoring out a negative doesn't change the expression itself. And a negative divided by a negative is just simplifying it further. Yeah, these are same exact answers. Yeah, Michael?
I tried to figure out the domain by finding the range of the original function. I don't know how helpful that was. But I had like a problem where I looked at that and I said, there's no possible way that like I could have an output greater than 1. So that's when I didn't, right? Because the range of the original is the domain of the inverse, right?
Yeah, that's correct, but your output can be greater than 1, right? If you solve for 100, you're talking about for the original function, 100 is equal to x plus 2 over x plus 6. Just cross multiply and solve for your x values. 100x plus 600 is equal to x plus 2. And then we get 598 is equal to negative 99x. So x is equal to 598 over negative 99. That is a negative value.
Like, I was like thinking, like, if you plug in for X, like, if I put infinity there, it would be like 1, or it would be like this, like infinity over infinity. But if I
See-
put negative infinity, it would be a negative infinity over negative. Be like,
Yeah, well, you're looking, be careful. You don't want to put putting negative infinity there, helps you with identifying end behaviors.
right.
But it doesn't help you it helps you identify end behaviors. And so when you're sketching out the graph, that's very useful. But it doesn't tell you what your range is. Your ranges can be a little intimidating because a lot of the time you want to look at your graphical representation to find your ranges of functions. However, utilizing the tool of the domain of the inverse is the range of the original, and the domain of the original is the range of the inverse, helps you solve your range and domain from a technical standpoint without graphing involved. And so, yeah, plugging in infinity isn't gonna give you the bounds for the range. It's only gonna give you the end behaviors. And when we're looking at a function like this is essentially a reciprocal function. So we're looking at a function that looks like this. So you're gonna have vertical asymptote take place. And I think that's what you were confused at when you were plugging in that infinity, because it's shooting up. But it's still representing every single value in the real number system except 1. Any other questions? All right. And then the last question, question 4, we are given 2 functions, f of x and g of x, and we just want to find their compositions of one another. So let's do f of g of x first. Wherever you see your f of x, we are going to look at our x and create some parentheses. So f of g of x equals 3 parentheses plus 5. And then inside those parentheses, we're going to put in our g of x. And then you just want to simplify. Lucky for us, 3 divided by 3, dealing with products here, those cancel out. So we really just have x minus 5 plus 5, which just gives us x. Sorry. And now let's do g of f of x. So wherever you see a g, we're going to look at that x and create our parentheses. And then inside those parentheses, we're now going to fill that with our f of x function, which is 3x plus 5. And now we're once again going to simplify. 3x plus 5 minus 5. Easily see that the 5's cancel out. And then 3x divided by 3, the 3's cancel out. And lo and behold, we get them equal to each other, which tells us what? They're inverses of one another. We didn't have to state that in this problem, but you might have to on the exam. Explain what was the purpose of finding these 2 compositions. Oh, well, they both equal the same values, so we're able to deduce that they're inverses of one another. All right, so this completes our quiz 5. I'm gonna stop the recording now.